Hi everyone, welcome back to our channel. Today we are going to solve problem number 32. The given problem is in the series RLC circuit, determine the response V naught of t in time domain for a given impulse input where V of t is nothing but is saying it is an impulse input. So Laplace of impulse input already we have been studied in the previous lecture, it is equal to 1. Now let us try to apply for this problem. So first these are in time domain. Let us try to convert all this time domain into frequency domain. In time domain we have, so this is time domain and this is frequency domain where we call S is equal to j omega or frequency domain. So this is R in ohms. In frequency also this is of same parameter R ohms. Here it is L Henry, and here in frequency domain we can write down it as S L ohms. Here it is written as capacitors in farad. Here we can write down this as 1 by SC ohms. When you look out, this is the concept of converting the time domain parameters into an frequency domain parameters. So I repeat again, R ohms, L Henry, SL ohms, C farad 1 by SC ohms. Now let us redraw the network. Here we are going to have an resistor, and after conversion this also will be a resistor and this also will be an resistor. This is the Laplace transform value is 1, and here we are going to have, so let us directly write down this as V input of t. Okay, later we will try to convert. Okay, so V input of t, this is of 2 ohm, this is of SL. So SL value is 1, therefore this is S ohm. Here it is 1 by SC ohms, and the capacitor value is 1 by S into 1, which is nothing but 1 by SC ohms. Okay, so now we need to convert this in the required format since all we transformed here. So this is the Laplace transform of after converting, which is V of S. Now here let us assume that the current of I of t. Now this current will be I of S. So now we need to find out, and here output we are going to get where this one is also V naught of S. Now I am writing the expression of I of S. I of S is equal to V input of S minus 0. You can see here the current travels like this. Okay, so current I is equal to, the formula we have is V by R. Therefore I of S is equal to V I of S minus 0 divided by 2 plus S plus 1 by 5. So this will be the equation. So now this is, let us assume this is the current linking input voltage. Let us try to mark as equation number 1. So here the current which flows in this branch is I of S. The same current I of S I am going to write down, especially with respect to this node. Okay, so especially with respect to this node I am writing the current I of S. The current I of S is equal to V naught of S minus 0 divided by 1 by S. Okay, so now this is the second equation. You can see here this all three resistors are connected in series connection. I can say that current is same or current is constant. So I can compare first equation is equal to second equation. Then I'm going to get V I of S is equal to 2 plus S plus 1 by S, that is equal to V naught of S divided by 1 by S. So we need to find out V naught of t. So for that what we are going to write down it is V I of S, already we had solved it. V I of S is nothing but an impulse signal. Then you are going to get the Laplace transform of V I of S value is equal to 1. So bring this down to the denominator, which is V naught of S divided by V I of S. The input is nothing but 1, that is equal to 1 by S divided by 2 plus S plus 1 by S. Okay, now Let us try to solve it in a required form. Okay, so when you solve it in the required form, so this is 1 by s divided by, take the LCM as s. This is nothing but 2s plus s square plus 1. S will get cancelled. Then we are going to get 1 divided by s square plus 2s plus 1. This I can write down it as 1 divided by s plus 1 whole square. Okay. So now successfully we have been obtained v naught of s is equal to 1 by s plus 1 whole square. Okay. So this is like Laplace of t to the power n is equal to n factorial divided by s to the power s plus 1. Okay. So here it may be having, so this is in this format. So Laplace of e to the power, so here it is plus, no, e to the power minus at t to the power n, I can write down it as n factorial divided by s to the power, this is minus, here you will be getting s plus a whole to the power n plus 1. So when you expand this in that format, 1 factorial divided by s to the power 1, 1 plus 1. This is both are same. So when you see here, the value of a is 1. So I can write down this as t to the power n, t to the power n. So n value is how much? Here n is equal to 1. Okay. So this n value is equal to 1. I can write down t to the power n is how much? 1 into e to the power minus a. What is the value of a? 1. E to the power minus 1 into t. So the ultimate equation is t into e to the power minus 80. Just to compare this equation with this equation. Therefore the value of n is equal to 1. The value of a is equal to 1. The formula is e to the power minus 80 into t. This is the ultimate formula you are going to get when you are going to apply inverse Laplace transform, which is v naught of t, which is the output equation of the given problem. Okay, so this is the procedure of solving. Okay, so the Laplace transform here is very much useful. Okay, so in time domain it is r ohm, here it is r ohm, here it is L Henry, it is SL ohm, here it is C farad, this is 1 by SC form. So when you represent in this format, this formula will help you to convert the given answer. So if you feel my explanation is good, please give a strong like those who are watching the video, and please share with your friends those who are studying this same subject. And if you are watching my channel for the first time, please subscribe to my channel with the name KV Tulasi. Kindly support this sort of a free channel for the development of students and faculty. So still, if you have any doubts, if you are unable to understand at any point, let me know in the comment section. I will answer your doubt. Thank you for watching the channel, or thank you for watching the content. So if you are just observe this video, nothing you get, just do the problem of your own again by writing only the question. Just if you are unable to understand, just listen the explanation again and again, then automatically you can understand. Very simple, the method of solving. Thank you for watching. We'll meet in the another video.